Thank you, Yana. It's going to take me 12 seconds to get the tech stuff correct. Okay. I am co-presenting today, and what Yana did not say, and I appreciate her not saying this, was I was here for 8 years, and my co-presenter, Erik Jules, has been here for 16 years. That's 24 years if you add those two numbers together. And I think collectively we've written 3 papers on redwoods. So I am the last person that should be giving a talk like this, which is going to make this, I hope, really fun for you. But Yana asked me to do this because I think she was hoping that I would instigate something, that I would provoke. And so that is what I'm here for. And I'm looking forward to talking to you about enigmas. What is an enigma? It's an important, I think it fits really well redwoods and fire. If I can read or cherry pick this portion, the second meaning there of enigma, a perplexing, baffling, or seemingly inexplicable matter, person, etc. And something that is enigmatic has this perplexing, baffling, and that link to obscure. And to me, when I arrived here, even when I interviewed for my my faculty position at Humboldt State, I was confused by redwoods and fire. My first visit to redwoods, I was hugging a tree and getting a picture of it and taking a picture of the canopy and taking a picture of goose pens and basil hollows, and they sat on my mom's refrigerator like they did on probably your parents. But it was so weird to be in a place that was bathed in fog, yet the effects of fire were so obvious. And I think that a lot of you also struggle with this. There we go. So I was taught, as many of us were, and we use it in our language, that this system, these landscapes are rainforest. And what I'm going to do today is, I'm not going to argue the other side of this spectrum, but I think that us looking at rainforest simply is the wrong idea. And I think embracing this dominant disturbance that is fire in redwoods is valuable for all of us, and I think it's a good thing to talk about. So I'm going to use this really bad term, fire forest, because it's, to me, about as silly as the idea of this being a rainforest. So the first thing, that's fire in redwoods. That picture on the left could be the one that is on my mom's refrigerator, but it's a picture that Lenya took yesterday walking through the canoe fire. Hopefully many of you also took that tour. My favorite model, Hugh Scanlon, is here on the right, and it's what I think is an awfully provocative photo as well. This is a picture from the canoe fire during it that Stephen Underwood took. We see this evidence. All of us have seen it, and I think all of us have scratched our head a little bit about it, fire in redwoods. Further, if you look into the fire history record, I'm a fire ecologist, and one of the things we're interested in is understanding characteristics of a fire regime. Of those, fire frequency really is the dominant characteristic. So you've likely seen some of these this week if you've attended any of the fire sessions. The time is there on the x-axis, and this is a number of individual stands, and those little triangles indicate fire scars that are hopefully dated to a certain year, and you tend to see general patterns. The pattern there is there were a lot of fires, and then there were no fires, and that's a pretty common pattern anywhere you are in North America, right? This map here on the right shows the number of those sorts of studies. This is now a little dated, a decade old, but the number of those studies and the values there represent the time between fires. Fires were really frequent across the range, whether we're talking about Del Norte County or Southern Oregon, all the way to the Chaparral and Shrouded South. That's weird for a rainforest to have fire frequencies that look like ponderosa pine. Clearly fire was pervasive. The other thing, the part of fire ecology that I focus on is how individual plants survive. I work on tree mortality, and it's a hard thing to work on in redwood because the dang things are very difficult to kill. There's a picture of a tree from the canoe fire. That was an area that had this sort of monumental landmark sort of fire. But redwood has this suite of traits, and if I'm looking at longleaf pine in the southeastern United States or ponderosa pine in the northwest, we look for these traits. How do they survive? A plant has very thick bark. That'll help it survive. A plant can prune its large lower branches to keep them away from fire. That also helps. Being tall helps. The tallest tree in the world. And then there's also this sort of Swiss Army design that redwood is one of the few trees that has that. That is that they can resprout. They can use thick bark to protect themselves, but if all else fails, they'll just resprout, and they can sprout from the base, from the crown, etc. It's really pretty unique for a conifer to be able to do that. And then they tend to germinate best, although not only, in fire-cleared soil. It also has a unique trait. Redwood sustains fires pretty dang well. And this is usually shocking to people. Our lab and Jeff Kane's work now at Humboldt focus a lot on the flammability of plant communities. How well do they burn? And if we were ranking them, and if I asked you a very quick quiz, anybody in the western United States, what are the two most flammable litters or two most flammable trees in the west, you'd all say ponderosa and Jeffrey pine and stumble over each other. What's your guess on the third most? All the western conifers. Coast redwood is. A species that we call a rainforest has this trait that makes it burn almost as well as Jeffrey pine and ponderosa pine. That's really weird, and that gets at this idea of an enigma. What were you going to guess? Maybe giant sequoia at number 8. It is enigmatic. I think it's shocking to me anyway. If you look at some of the species that co-occur besides others, coast redwood there at these generating really tall flames, and the co-occurring species like western hemlock, Douglas fir, that burn very poorly. So there's a mystery here, and that gets at that enigma, a mystery, something that is a little bit confusing. This crazy fire history occurring in something that we like to call a rainforest and like to think about as a rainforest. And so as related to that, what people have looked at is the origin of those fires. Where do these fires come from that show up in their fire history record so obviously? Did they come from within, or did they come from outside of redwood forests? Let's go through those a little bit. I got my PhD at the University of Florida. It's about 47 miles north of the greatest lightning strike density in the United States. That's just north of Disney. And I was very surprised moving here at the contrast in climate. Lightning is here, though, and lightning is certainly in the Redwood region. If you spent time in the Redwood region, lightning also ignites fires, and ignites quite a few fires. And part of that, I think, in the comparisons made with lightning, they often compare lightning to the Sierra lightning strike density. Sierra has lots of fires. We all know that. We can't escape it in California. But lightning is still present in these landscapes. It's just at a lower level than the Sierras or the Klamaths. So one of the sources of fire from within is lightning. Another is, I took this photo. It may show some other stuff, but I really took this photo. Another really neat source of fire here is what we call holdover fires. Fires that burn in logs or in redwoods, almost uniquely on the planet, that burn in what Steve Sillett calls arboreal histosols, or what I would call crown duff, accumulations of organic material up in individual trees. And these, as many of you have observed, are a lot like Roman candles in fires. If these little areas ignite, you can imagine at these heights what that might do. So these holdover fires, also another source of fire from within. I think the typical, and this is what in the end, we'll come back to this, and I think to me, it's a very heavy topic. People attribute fire in redwoods almost always. They say something about the fire history record was really, really frequent. They go, well, it was the tribes, it was Native Americans. They're burning like crazy. Almost like they're saying, oh, it's not real, it's not natural, it was just Native American burning. And I want to come back to it because I think it has a lot of, in the talk today, why it matters is how we'll end, and I think that's an important point. But it is pretty clear that the tribal density in the Redwood region was pretty high. And lots of diverse tribes, they were burning for lots of different reasons, and lots of evidence for them using fire in redwood ecosystems. Okay? So all of those examples were fire originating within Redwood and spreading within Redwood ecosystems. The other way is fire coming from the outside. And this is something that always surprised me, the sort of a lack of, I think, an appropriate recognition for fire outside of redwoods moving into redwood landscapes. On the right here is a picture of the beautiful Bald Hills of Redwood National Park, a place that is widely acknowledged to have had frequent fire in its history. It's a landscape that could support Douglas fir forest, but because of burning over millennia, it somehow supported open savannas and woodlands. Chaparral at the southern end. But all of the ecosystems, if you think about the sort of inland abutment of redwoods, are adjacent to frequently burned ecosystems. What is as I was spending a beautiful day in Arcata yesterday, the characteristic of September, what's the wind direction, Lionel?
In the morning out of the east.
This beautiful east winds, right? It made Arcata the most beautiful place in the world for the month of September, it seemed. Those east winds are pretty strong. They're not as strong as Santa Ana winds, but they are a very similar sort of form of winds, and they can easily drive they drive surface fire behavior and prescribed fires frequently, but they also certainly play a role in bringing fire into these landscapes. So fire from within and fire from outside, that's a pretty diverse sources of fire. And I think what I hinted at earlier, what stops fire in this region? The canoe fire was a great example of fire that moved across a region that bounced over creeks. It can shower embers across rivers. These systems can generate fire and make the landscapes pretty burnable. Okay, so getting back to this thing I hinted at, this climate or humans. I understand that I'm setting up a goofy little dichotomy, but it is important to talk about. So I think I said earlier that people sort of relegate fire to being human-caused in the region. If fire was human-caused, there's a list of characteristics we might expect. If you don't burn during a certain day or two or the last couple months, certainly you don't. If you were a human burning this landscape, you wouldn't ignite a fire during the worst fire season, or during the worst part of the fire season. You'd burn it either before or after. And so you'd see a dampening of the seasonality. It wouldn't be very correlated with climate, because if you're going to burn, you're going to burn. If you're burning for basketry materials, if you're burning for certain foods or for habitat, you're just going to burn. So that should be less correlated with climate. They also would be pretty small. You don't want to ignite a 1 million acre fire. Clearly that would be problematic, and so the fires should have been smaller. And then we'd also hope that, or you would expect that they would be relatively non-random in their location. You'd burn next to a village site, not 100 miles away or in a faraway spot. And that likely the lowlands would have a greater fire frequency than the uplands. That is, near your location, you're going to fire safe your dwellings, you're going to fire safe your village sites, and you might also be burning in sort of an agroforestry standpoint. If climate was the driver, you'd see a strong seasonality, you'd see a really strong link to climate, you'd tend to see large individual fires, and they would pretty much be, or mostly randomly placed. At least the uplands would be more dominant than the lowlands. And there's not a model, there's not a paper I can point to. I'm not going to stand up here and give you data, but there is a model for this. There's a neat paper that was done on Whiskeytown. And here's the same thing we looked at earlier. You can see the years here. And instead of triangles, there are just these little vertical lines that show the location of the fires over time and across these individual stands. And what these researchers did, this is Scott Stevens and Danny Fry, they broke up these individual graphs into time periods that matter. This has been done in other locations. But getting at this human or climate contrast, you can see here, if you take this 1850, which is a great date across California, you see the pre-contact, or at least the predominance of contact here, the wind-to period. What's the characteristic of those individual vertical lines? They're all over the place. Right? Can you pick out a pattern? We're really good at seeking pattern. It's hard to see a pattern to the left of that red line. You take that next leap until 1925, when there was effective fire suppression in that area, and what do you notice with those lines? They line up, right? You're all doing this right now. They line up really well, and that shows a really tight link to climate. So you shift from a tribal-dominated ignition pattern to a climate-dominated ignition pattern, and then what's this last phase? We're really good at this, active fire suppression. Okay, so this is a sort of way, or what Erik and I have termed a path forward or a holy grail of understanding redwoods and fire. We can do this sort of thing in this region and get at that sort of question. And I think it's an important question. It's not just an academic question. I think it's important to have something in there that I want to get to. And here's the design. If anyone is looking for this, we're not going to do it, so go for it. Seek a climate gradient, locate village sites, cross-state the trees. This is not trivial. Sample a lot of trees and seek a lot of fire scars. The work that Alison Carroll and Steve Sillett and others have been working on certainly is getting at this now, and it's exciting, I think. Why does it matter? The exchange with Jana about this talk was, here's the title, and I sent, and why does it matter at the end? And she said, sounds great, and then I texted her immediately and said, hey, take out the why does it matter part. And she said, I'm not going to take it out, I'm entering it right now, click. Too late. But it does matter, and so what I hope to do now is to convince you of that. The first reason it matters is the way we look at redwood forest. This is Jedediah Smith, pretty classic northern redwood. You can see there's sort of a hump in the middle of that photo that goes from the top left to the bottom right. That's a nurse log. It's a redwood log. And what's growing on top of it is western hemlock. This is a classic nurse log of the Pacific Northwest forest. That's a rainforest. This is canoe fire. This is, those are the logs that would have supported, this is actually logs that were recruited, but logs that would support something like a nurse log. If we acknowledge that fire plays a role, then we have to acknowledge that some of those characteristics of these fire-excluded landscapes are likely relics or products of fire exclusion. I think that's a hard thing to wrestle with. So maybe this picture of redwoods that we have on the left is degraded from fire exclusion? Question mark? And the picture on the right is more like what redwoods look like? Question mark? I think that's a hard thing to struggle with. We looked at down wood in Bull Creek Flats and in the canoe fire. And we did the most extensive downwoody debris survey ever done, 8 kilometers of work to look at this. And what we found was some stuff. The most important of which is this last little red box at the bottom. Those are really large logs. Redwood has the greatest downwoody biomass of any ecosystem in the world. And if you look for these heavily decayed logs, which are those logs that create those nurse log substrates, what happened in the canoe fire? Not a single log of that most decayed state remained. They were all consumed. So again, this top left picture, can we see that? I think you understand. I think it matters, and I hope that it is a little bit challenging to think about. Beyond that, I think it calls into question tree dynamics. There's been work done in post-fire landscapes, in post-fire redwood to look at tree dynamics. What does this mean for understory composition in these landscapes? And what does that mean for animal habitats? One of the interesting observations from that period, from the post-canoe fire, was independently, Steve Norman from the PSW station in Arcata and our group from Humboldt State visited a site in the canoe fire and noticed we're missing sword fern. And my first vision of a redwood forest was a Star Wars-esque speeder that was moving through. And so I saw sword fern as being, of course, that's what redwood forests have. In the canoe fire landscape, sword fern has been reduced by more than 95%. Again, looking at these landscapes, not seeing a nurse log as part of this dynamic, and perhaps not seeing it dominated by sword fern. I hope that that's disturbing to you, because it is to me. Okay, so again, why does it matter? The interesting thing, when I arrived here in 2004, all they could talk to me about was going to do work on the canoe fire that happened last year. And they said what a freak occurrence it was, ... And if you remember that time, you remember what a big deal the canoe fire was. Well, what happened in 2008 in Montgomery Woods? In 2008 in Big Sur? And if we were to do a crystal ball, I had this talk set up, months ago because I'm so well planned usually. Soberanus is burning through the footprint of the 2008 Basin Fire. So I think that these sorts of, why do we need to understand how fire interacts with Redwood? Because fire is going to be there, and our future looks awfully smoky. And so I think it's important that we embrace fire in this way. And here's just the irritating when I'm trying to irritate all of you with this. Yana introduced me and said that I do work all over North America, or in places in North America. I do work in oak woodlands in North Mississippi, longleaf pine in the southeast, to start this list of places that when I mention them, you all think of fire. And in all those places, there is a fire community that has a research community and a management community that works very well together, and they have lots of prescribed fire studies and lots of examples to start to tease apart how we replace lightning ignitions or human ignitions, or how we manage these landscapes with fire. And I think to a large degree that's lacking here. And the communities that are here, they started a prescribed fire council movement in the western U.S. That's really powerful and cool. The managers in this region that are working in fire and in Redwoods are phenomenal. And I think getting from sort of saying, yes, fire happened, to what do we do with fire in the future is a real, I think it's a huge challenge, and I think it's exciting, and I hope people get excited by that, because I know that I am. So I do think it's a solvable puzzle, this enigma. There's evidence, and it's strongly suggestive from fire history and the life history evidence. I think they say the story is pretty clear. Research can help disentangle this. I think Erik and I put forth sort of a model on how something like this might take place. I think the Redwood region is perfectly set up for this sort of analysis. And certainly research can help with how does fire affect ... And I think it also offers these options for adaptive management in this region. Applying fire like it has been done in the region has been at a really small level, and all those who use it would agree. But starting to get at what are the lessons from that? And I think that's been some really, if you compare this Redwood Science Conference to the previous Redwood Science Conferences, there's a lot more talk about fire here, and I think that's exciting. So I think there's a lot of really near-term options for adaptive management in this system. And most of all, I hope that this talk provokes some thought on redwoods and fire, because I think it's a really neat topic, and I know that you all care about redwoods. And with that, I'll close.
Anyone have a question? Oh, here we go. Hi, great talk and presentation. Just quickly, I was struck when up in Jedediah Smith Park that there wasn't the fire scars that we have down here at Humboldt Redwood State Park. And so I wondered if you could, and there were tribes up there, right? So I'm wondering if you could talk about that, because like the Boy Scout Trail, man, there's like no fire scars.
Yeah, depending on where you are in Jed Smith, there's some pretty extensive flats. That picture is kind of a cheating picture. That's that spot there between the highway and the river. That's extensive flat where western hemlock is pretty dominant. So it is less, and that area is wetter. If you look at the lightning record, the lightning strike density and number of fires is greater in the northern region than it is anywhere else, and so Jed Smith should have that. In the slope forests, above the flats, you tend to have more. But certainly there's some really extensive along the Smith where fire was likely pretty rare. But that juxtaposition of alluvial flats and these slopes, it's an important question for fire. We have models from other landscapes, other ecosystems, where we understand that sort of that push and pull or tug with wet forests and dry, and how fire may have manipulated that ecotone. But in redwoods, we don't have that. We don't have that understanding.
I guess I'm just wondering what the secret sauce is elsewhere where prescribed fire is more common. And the one thing I was struck with your photo was it was flat. Does topography have something to do with it, as an ease of containment or ease of putting fire in the landscape? Is that part of it?
Ken's head just rolled back. There are a variety of reasons. There are some social reasons. Different regions have embraced fire, whether they never lost the cultural connection, so the Southeast, if you look at burning across the United States, the Southeast is by far the leader. And it's not from a lack of human density. The number one state for prescribed fire is Florida, which is in that region by far the largest state by population, by far the largest state with in-migration, by far the largest, or the oldest state in the region. All the things that we think about that are impediments. You know, the folks from the Great Lakes don't like to see fire. Yes, they do. They're burning all the time. So there's some social sorts of impediments. There's some real difficulties in burning in some of these landscapes. Redwoods offer some benefits that other ecosystems in California don't have. Fuel moisture in grasslands or in chaparral is frightening, but those same kind of sorts of problems don't exist in redwoods. So it's a complicated. There's some operational impediments. There are clearly some sociocultural impediments.
So, Morgan, thanks for the talk. It was really good. And
it was all for you. It was all for you, Lee.
I appreciate the photo of the old growth and how green it is, and calling that degraded. That makes my world.
Good.
But my question is more on second growth forests, because you focus on old growth and fire, but we deal with second growth forests that are truly degraded in many ways. And we are thinking about the use of fire. But when it comes to fire return interval rates, how does that apply? Those are established for old growth systems. How does that apply for this novel type in the last 50, 60 years, maybe a little older in some spots?
Yep.
How does it apply fire history return interval rates to those?
That's an awesome question. So when I arrived here, I read John Stewart and I had very long conversations about this, and I said, there have been so many fire history studies, but the corresponding application of fire to forests and what happens to them that's a really small number of studies. Why the difference? And it's an important difference. In the Southeast, for longleaf pine ecosystems, a lot of you have heard about them. They're really frequent fires. There were no fire history studies done, but the volume of studies on the effects of fire on you fill in stand condition, on seedling stands, on reproduction, whatever it was, that stack is like this. They were applying fire and measuring it. And only recently did they do any fire history studies. They found exactly what one might expect. But I think that there's a great potential to do that sort of work. In old growth, sure. But using fire history as the model may not be the way to manage, right? You're managing for objectives, not to, except in some cases, to emulate what was there. So I think that the stuff that y'all are doing, that's the stuff that needs to be reported on, because that's the condition that people are going to be burning in the future, hopefully.
Wonderful, Morgan. Thank you very much.